Sum and difference identities. So we're going to do a little investigation here. We're interested in the sine of the sum of two angles. And we're wondering, is there a connection between that ratio and the sine ratios of the individual angles? I mean, maybe these two things are equal. Maybe you can just take the sine of the first and the sine of the second and add them together and get this answer. Let's find out. For the first one, I can easily work this out because 30 plus 60 is just 90 degrees. And sine of 90 degrees is something we've worked out many times. I can go to the unit circle. Here's 90 degrees. This is the point 0, comma 1. The sine ratio is the b coordinate, and so this is equal to 1. For the other expression, sine 30 degrees plus sine 60 degrees, I can draw some quick reference triangle pictures. So let's see, 30 degrees, we've got 1, root 3 and 2. Sine is opposite over hypotenuse, so sine of 30 degrees is 1/2. And let's see, sine of 60 degrees, same triangle, right? Just different angle right here. So now I've got 1, root 3 and 2, another 30, 60, 90 right triangle, and the sine ratio opposite over hypotenuse, square root of 3 over 2. And so this is equal to 1 plus the square root of 3 all over 2. Now that certainly doesn't look like it's the same as 1. I better check on the calculator. Let's see, so I want to type 1 plus the square root of 3 on the top, arrow out to close the parentheses, divided by 2, and I get 1.366. So obviously these two expressions are not equal to each other. The sine of the sum is not equal to the sum of the individual sine ratios. That still leaves us wondering, is there some connection between the sine of the sum and the sine of the individual angles? And the answer is yes, and those relationships are called the sum and difference identities. There are 6 of them listed here. The cosine sum identity, sine sum, tangent sum, and then the 3 difference identities. And each of these identities links up the trig ratio of the sum or difference with the trig ratios of the individual pieces. And you'll see there is a relationship. It's just a little bit more complicated than we thought. We were working with the sine of a sum, and it turns out there is a relationship. You can calculate the sine of a first plus second angle by taking the sine ratio of the first angle times the cosine ratio of the second plus the cosine ratio of the first times the sine ratio of the second. That's the relationship. Now, you say, where do these things come from? They look so complicated. They are a little bit difficult to prove. I'm not going to do that here. You can take a look in the textbook if you're interested in that. We want to focus on understanding what they say and then learning how to use them. Let me point out a few patterns, particularly with the cosine and sine identities. What I always remember about the cosine ones is that they go cosine, cosine, sine, sine, right? Both of them, cosine, cosine, sine, sine, but the minus and the plus changes out. So when this is a plus, this is a minus. When this is a minus, this one is a plus. The sine identities, on the other hand, alternate the ratios, sine, cosine, cosine, sine, sine, cosine, cosine, sine, but the pluses match and the minuses match. So that may help you in terms of committing these things to memory. The tangent ones are probably less necessary to commit to memory. Well, let's test one of these identities out by returning to that example that we looked at, sine of this sum. Now we've already worked it out. We know this is sine of 90 degrees, which is equal to 1, but let's see what the identity tells us. That would be this identity right here, and it says the sine of the sum is equal to the sine of the first angle times the cosine of the second angle, right? I'm just reading along, following along here with what it says, plus the cosine of the first angle times the sine of the second angle. Well, these are all things that we can determine. Again, it's those reference triangle pictures, the same ones we had drawn earlier. Here's the one for 30 degrees. And you can see sine of 30 is 1/2. Let's see, we've also got cosine 30 is square root of 3 over 2, so I'll fill that one in. The other two, I'm going to need a 60-degree reference triangle. And so in that picture, cosine 60, let's see, that's adjacent over hypotenuse, so that would be 1/2. Plus, we did cosine 30, sine 60 would be opposite over hypotenuse. And now let's work out these pieces. Multiply across. 1 times 1, 2 times 2. This comes out to be 1/4. On this one, root 3 times root 3 is root 9, which is 3. Again, 2 times 2 would be 4. And 1/4 plus 3/4 is 4/4, which is equal to 1. So the identity worked. It gave us the answer that we expected. Again, these identities help us to link the trig ratio of the sum of two angles with the trig ratios of each individual angle. Thanks for watching.